going to do. I'm not sure exactly what happened. For some reason, its odometry thought that it was about 3 miles away from its current location. It just skipped. Yeah, and we just restarted a couple of times, reset the cables, and now it works, and we don't know why. So we did a lot of experimenting with a lot of different techniques. We tried mapping, we tried localization, we tried both. We tried wall following, we tried different exploration strategies, and most of them failed. We're not sure, we tried using some standard ROS packages. We're not sure why mapping didn't work exactly. Never quite found out. We tried implementing localization by building a particle filter and just taking the shape of the walls that it saw. Also not sure why that didn't work, but we've only done it in the last 2 or 3 days, so we didn't have time to debug. And ultimately we went for the simplest solution we could think of, which is compute the path offline. Give it, the path is basically a set of waypoints at which the robot should be able to see blocks. At each waypoint it stops and goes into a visual servo mode, which Eric will explain better how it works. It's really reliable, which is very nice. And then it comes back to the waypoint it was in, so that it can go to the next waypoint, knowing that there's a collision-free path to the next one. And that's all that it's doing. And we're entirely relying on odometry to know where it is. So we're expecting at some point it will fail, but if odometry doesn't fail too much, we should be able to go around the whole map.
At what point will it decide to build a structure?
Every time it has 4 blocks on its back.
So you could get a series of structures here, hopefully.
Oh, a village.
Wow. No one saw that.
And so the way visual servoing, actually, pause for this. This is the good part right here.
About the structure.
So, because we moved over to the new version of ROS, we had to re-implement. So, and we now have this cool RGBD camera, the Kinect style thing. So basically, what we're doing is using a 2D image to calculate where the blobs are, using like HSV filtering, sort of like we did with in the lab. And then we use the depth data at the given central points to find the location, so we can get a proper pose detection for the block, which means we can do really nice proportional control to the blocks, which is very reliable and fast.
So you're only navigating to known blocks?
Yeah.
Okay.
Will it do anything if it sees something?
No.
No.
Unless it gets in its way. Like, once it finds a waypoint, it's going to put its arm down in visual servo, and so if it's going to go to the closest block by close distance in the XY plane. So if there's a block that's closer to it, a head waypoint, it could possibly go to that one. So it would then retreat anyway to its original.
Does that choice prevent you from picking up a tower you've already put down?
No. Not
Not necessarily, yes. We saw that happen a few times, and it's super awesome.
It just kind of flings the blocks back.
You just put 2 in the collection.
Your bump sensors?
No.
It's done when we hit the wall.
We're relying entirely on dead reckoning right now. So the waypoint navigator is actually has some smarts about which directions to go in, and it will go backwards if it sees that it's the fastest way to go. In this case,
Oh.
Is it stuck?
Is it seeing any blocks?
It's not touching the